Yo, what's up? This is LeetCode 226, invert binary tree. So we're basically given the root node of a binary tree. We have to invert the tree and then return its root. So inverting a binary tree is essentially, we start at the root node and we have to swap the child node of every node in the tree. Okay, we have to swap the child nodes of every node in the tree, right? So we start at 4, 2, and 7, they have to get swapped. I guess they call it inverting, but I'm just going to say swap, right? So we have 2 and 7 for 4. We have to swap 2 and 7, right? Then the child nodes of 7 have to get swapped, so 6 and 9 goes to 9 and 6. The child nodes of 2 have to get swapped, so 1 and 3 goes to 3 and 1. Okay, so that's how we invert the binary tree. So we're going to use a post-order traversal, but at the end I'll show you kind of a more succinct solution that is pre-ordered traversal. Now again, post-ordered traversal is we go all the way down and then we work our way from the left to the right, basically, right? And pre-ordered traversal is we basically we don't have to go all the way down before we start doing anything. We just go left, boom, 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 right? So first of all, pay attention to example 3, right? If we have an empty root, meaning we don't have a root, we're just going to return nothing, okay? Right? That's an edge case we have to handle. Okay, so first of all, let's do this recursively. So we're going to do... So the way our solution is going to work is basically we're going to go all the way down, and we're going to set this equal to the left. Then we go up. This is going to be set equal to right. Then we basically go back up to 2, and we swap the left and the right. Now, if we had more child nodes, obviously it'd be a little bit different, because if this 3 had a 1 and a 2, we would have to swap these first before we can swap these, right? Like just in the code, like recursively, we would swap the child nodes of 3 before we actually swap 1 and 3. Okay, so we're gonna say left is equal to invert tree root dot left, right? That's gonna be our left. Then we have to swap, and this is our right. Then we have to swap. Okay. Basically we do. So if we go back up to the 2, how do we swap the 1 and the 3? Well, we say root dot left is equal to right, and root dot right is equal to left, right? And then we can return the root, right? And recursively, that is how we solve this problem using post-order traversal. Okay, but there's kind of a more succinct solution using pre-order traversal, right? So we can say, let's just do this, okay? And now we'll do the swap when we go down. When we start at the root node, we do the swapping, and then we go down, we do the swapping, right? And so that's how we'll do it in like a pre-order traversal fashion. We don't go all the way down and then work our way up. We basically work our way down, okay? And so we start at 4, we swap 2 and 7, then we go left, which I guess technically after we do the swapping, it would be 7 and 2. So we'd have the 7 here, we'd swap it, 2, and then we swap these. Okay, does that make sense? Although I think if we swap the 2 and the 7, we have to work our way from 7 all the way down, and then from 2 all the way down. Anyways, so what we can do is we can actually do the swapping before we actually make a recursive call, okay? So you do it like this. Now, in Python, when you do something like this, when you do root.left is equal to root.right, it doesn't overwrite root.right, okay? So that's why you can do root.left is equal to root.right, and you can do root.right is equal to root.left without any problems, okay? Because as long as these assignments are done in the same line in Python, they're not going to get overwritten. So we're not going to have an issue. Now, if you're using another language, you might actually have an issue, right? But not in Python. So this should work just fine. As you can see, the solution is a little bit more succinct, but it still solves the problem nonetheless, using pre-order traversal instead of post order traversal. Okay, so I hope that helped you. And yeah, I'll see you in the next one.